All right, so we're going to go through questions 4, 6, 7, and 8. You guys really only asked to go over 4, 6, and 7. 8, I just want to make sure that you guys all know how to do. Um, Only like one or two people asked for help for that one, but I'm just going to make sure that we're all on the same page with it. All right, number 4. This one is 100% something like this will be on your quiz because it's forcing you to make sure you understand why we're picking the points that we pick to test. So from here, remember, you will need to identify your slope and your b. And our form that we normally graph is y is equal to mx plus b, where m is equal to our slope. So it's telling us our rate of change. And our b is equal to our y-intercept. So it's where we cross our y-axis. So the b is the numbers being added or subtracted to our variable. Well, there's no number being added or subtracted. So the number that represents nothing is 0. So b is equal to 0. And remember, I do want you guys getting in the habit of writing it as an ordered pair, because that's just allowing for you to continually see that in our y-intercept, x is 0. So without you realizing it, it's reinforcing this idea to you over and over again. So the first thing we do is we plot that b, where we cross our y-axis at 0. And then our slope is a number that is being multiplied to our variable, and it's telling us how we're changing. So every x we're plugging in is changing at this rate. So our slope in this case is equal to 5. So some of you are putting 5x. X is not part of our slope. X is the variable x. So our slope is a number in front of it. If you put x in there, then you're saying that part of our slope is unknown. So it's just 5. All right. And remember, our slope is our change in y over change in x. So when we have that 5, you can write it over 1. So this way you can see and identify exactly how our y is changing with our x. So our y is changing in a positive 5, while our x is changing in a positive 1. So then I'm going to count up 1, 2, 3, 4, 5 over 1. And it can generate the next point. It's telling us, it's giving us directions. Remember, if I called you and said, hey, how do I get to your house? Well, you first need to know where I'm at, which is our y-intercept. And then you can give me directions, which is our slope. So we can go up 5 and over 1 again. All right. And we graph this equation. We're treating it like it's y is equal to 5x. So we're treating it like it's an equation. And then when we go to graph, that's when we have to make sure we're looking and saying, okay, well, this is less than. And since it's not equal to, it is going to be a dotted or a not solid line. So then you will take a straight edge. I can't use a ruler on this thing. It's not easy, so mine's not going to be perfect. But you'll take a straight edge, and then you'll draw that dotted line, creating two separate regions of our graph. And now this is where we're testing. We're saying one of these regions contains all of the solutions and the other region contains none. So normally we pick the point 0, 0, but we can't pick that because this one's falling on the line. If it's on the line, it's not part of either region. So we need to pick a point that falls on in one of the regions. So I'm picking point 1, 0. This one is easy to work with. And then I'm comparing 0 for y, so it's easy for me to identify. By picking this point, 1, 0, when I plug in 0 for y, so I'm picking the point 1, 0, when I plug in 0 for y, I don't even, like, if I give you like a sloppy fraction or anything, I don't even need to do any calculations, because I can say, will this number be positive or negative? And it just allows for me to be a little bit more direct with knowing if it's a solution or not. Because if the number is positive, then I know 0 is less than that. If the number is negative, I know 0 is greater. So it just allows me to easily compare. Well, 0 is less than 5. So this is a true statement. So that means the point 1, 0 was part of the solution region. Because remember, if one point works in it, they all do. So then we need to shade in this region here. And every single point in this shaded region will satisfy this inequality. So they are all the solution. All right. So let's go ahead and move on to the next one. All right. So for this one, off to the side, I'm just going to write it as 4x minus 2y is equal to 12. So I'm not even going to think about it as an inequality until after I know how I'm going to graph this. And there are two different ways that you can graph this. One way is we can use our intercepts, and the other way is we can rewrite it in slope-intercept form. This one I'm going to rewrite it in slope-intercept form just to practice that. And in slope-intercept form, we know it's y is equal to mx plus b. So it means I need to isolate and solve for that y. Well, this is a positive 4x, so to move it to the other side, I will do the inverse operation of it because we want to get rid of it on that side, so we're going to subtract it. So now it's negative 2y is equal to negative 4x plus 12. Well, we need to isolate that y, so I'll divide everything by negative 2, and remember, we do it individually. So now y is equal to, well, negative 4 over negative 2 is positive 2x, and 12 divided by negative 2 is negative 6. Once I do this, now I can easily identify what my slope and what my b is. So the b is a number that's being added or subtracted to a variable. So in this case, it's minus 6. So my y-intercept is 0, negative 6. The slope is a number that's being multiplied to a variable, so that is 2. So now I'm going to first plot my point of 0, negative 6. I know my slope is 2, so I can rewrite it as 2 over 1 because it's change in y over change in x. So my change in y is a positive 2. My change in x is a positive 1. So I'll go up 2 over 1, up 2 over 1. I got my 3 points. Now I'm going to draw my line. Now this is, once I plot those points, this is now where I'm going to always then go back to my inequality in the original problem. This is greater than, so I know it's going to be a dotted line. Once again, you'll use a straight edge, so your line will be better than mine here. And we're creating and drawing it into two different regions. Now that 0, 0 does not fall on the line, that's the point that we're going to use. And 4 times 0 minus 2 times 0, is this greater than 12? Well, all this is going to zero out because we're multiplying both numbers by 0. So is 0 greater than 12? False. It is not. So since 0 is not greater than 12, I know that that region is not a solution. So that means the other region would contain all of my answers. So I can color that in. If you want to check your work, pick a point from that region and plug in and see if it's true. But you only really need to pick one point to test, because if it works, then they all work. If it doesn't, none of them work, so we color the other side. All right, for the next question, I'm not going to rewrite it, but we're going to graph it in the form that it's in. All right, so for this one, once again, this is in standard form. So off to the side, I'm just going to rewrite it as an equation. I'm going to focus on this as an equation. And in standard form, I look and see, is this number divisible by both the number in front of my y, which it is for that one, and the number in front of my x, which it is for that one. So if I see that it's divisible by both of them, then I'm going to use my intercepts. And I'm going to solve for my x-intercept. And when we solve for x-intercept, we just simply set y equal to 0. So 10x plus 5 times 0 is equal to 20. Well, this is 0, so 10x is equal to 20. Now I solve for x by dividing by 10, so x is equal to 2. So when y is 0, x is 2. So that tells me where I'm crossing this x-axis. And then I'm going to solve for my y-intercept. So for my y-intercept, I set x equal to 0, which is why on your y-intercept here, I keep having you write 0 and then a number, because it's confirming every single time, oh, for the y-intercept, x is 0. And hopefully that can also build well for our y-intercept x's, or for our x-intercept y is 0. So now we say 10 times 0 plus 5y is equal to 20. This zeroes out, so 5y is equal to 20, divide by 5. So y is then equal to 4. So this generates a point of 0, 4. So that is my y-intercept, so I can put that there. And now I have 0, 4. All right, so now I look back at my original problem and say it's equal to, so this is a solid line. So once again, yours will look better than this because you'll actually be able to use a straight edge, unlike me here. All right, now I look and say, okay, what point am I going to pick? Because I need to color it in. Since 0, 0 does not fall on the line, I'm going to pick that one. So 10 times 0 plus 5 times 0, is this less than or equal to 20? Well, this zeroes out, and 0 is less than or equal to 20, so I know that that point is in the solution region, so I'm going to color it. All right, there's this one point now, or one thing that you have to answer still. So that's our slope. So once we graph this, just make sure at the end, if you don't have your slope written, count down how much from one point to the other. So we're going 1, 2, 3, 4 down and over 2. So that means my change in y over change in x was 4 down, so it's negative 4, right 2, so it's 2. Well, negative 4 divided by 2 is negative 2, so our slope is negative 2. So the only problem is if you do it in standard form, when you're answering this, you still need to tell me what your slope is. So you'll have to actually count from your one point to the other. And if it gives you a fraction like, say, 8 over 6, just make sure you are reducing that to 4 over 3. All right, last question. All right, so from here, we're working backwards now. You're getting a graph and seeing, can you give me what the inequality is for this graph? So the first thing I'm going to do is I'm going to look at these points that we have here. So we know it's going to be y, some form of inequality, mx plus b. So the two things I need to solve for are, what are my slope and what is my y-intercept? So we can go ahead and solve for our y-intercept very easily because we see that's where it crosses. So our y-intercept is 2. So b is then equal to 2. So right now I have y. Need to figure out the inequality, mx plus 2. All right, now to find our slope, just like we did in the last problem, I'm going to count up and over to my points. So I'm going 1, 2, 3, and over 1. So I went up 3 over 1, so my slope is then equal to 3. So now I have y, and then I have 3x plus 2. All right, so now some of you may be able to just read and interpret how your inequality is going to look from here. But what I'm going to do is I'm going to pick the point 0, 0. And when I plug this in, I'm going to see what type of statement it gives me because it's part of the solution. So I'm picking a point that's in the solution region, and I'm plugging it in for my x and my y. I'm going to plug it over here. So 0 is what to 3 times 0 plus 2. I'm picking 0, 0 because it's part of the solution region. And I plugged in 0 for x and 0 for y. Well, 3 times 0 is 0. So what is 0 to 2? Well, 0 is less than 2. So that means that this has to be less than. So our final answer is y is less than 3x plus 2. I know it's not equal to as well because it is a dotted line or not solid. All right, that is it for this video.